Hello everyone and welcome back to another video. Today we're going to be talking about the different forms of the equation of a line. So basically, how many different ways can you write an equation of a line? First off, we're going to be talking about point-slope form. This is y minus y1 is equal to m times x minus x1. It's the equation of the line that passes through the point x1, y1 and has slope m. So in order to reestablish this equation, this form, and this idea, let's solve an example. So find an equation of the line that passes through the point 2, 3 with slope negative 1/3. If we look back up, we're going to see that 2, 3 is going to act as our x1, y1, and negative 1/3 is going to act as our slope m. So with that in mind, let's set up our equation. If we're solving with point-slope form, we're going to want to set up our original form. So y minus y1 is equal to m times x minus x1. Once we have that in place, we're going to plug in our values for y1, m, and x1. And as stated before, 2, 3 is our x1, y1, and negative 1/3 is our m. So we're going to plug those values in. And then we're going to simplify by getting rid of the negative 1/3 over here so that we can get our simplified version down here. And just for reference, the form that this equation is in right now is called general form, which we will go over later on. Okay, now let's draw the graph for this equation. So the key parts of this line was that it passes through 2, 3, and it had a slope of negative 1/3. So we're going to find our point 2, 3. Here's 2, here's 3, here's our point 2, 3. And then since it has a slope of negative 1/3, the rise is going to be negative 1, so it's going to go down 1, and then it's going to have a run of positive 3. So it's going to go down 1, and then to the right 3. And you can see this with the triangles over here too. Okay, moving on, we have our second form, slope-intercept form. This form is y is equal to mx plus b. So this form is the equation of the line that has slope m, so slope m, and y-intercept b. Just for reference, y-intercept is where the line intercepts the y-axis. So if we look up to this graph, the y-intercept is going to be somewhere between 3 and 4, because that's where the graph is intercepting the y-axis. Okay, let's continue. To reestablish the idea, we're going to do an example. Find an equation of the line with slope negative 3. So we're going to highlight slope positive 3. And y-intercept negative 2. So slope-intercept form, we have our givens. Our slope, or our m, is going to be 3. And our y-intercept, or b, is going to be negative 2. So let's set up our equation in slope-intercept. Y is equal to mx plus b. We're going to plug in for m, and we're going to plug in for b because we don't know y or x yet. And then you get your equation. So this is your equation of your line. Y is equal to negative 3x minus, y is equal to positive 3x minus 2. And using this information, we can graph the point and graph the entire line. So if we have a y-intercept of negative 2, that means that the line is going to cross the y-axis at negative 2. So we graphed our point right here. Then, if it has a slope of positive 3, we're going to have a run of positive 1 and a rise of 3, giving us the slope of 3 divided by 1, or 3. So we're going to run once to the right and then go up positive 3. You can also see this along the triangles too. And this is your graph for example number 2. Of slope-intercept form. Let's continue on. So another thing you're going to find quite handy is converting an equation to slope-intercept form. So here's an example. If we have the equation 2y minus 4x is equal to 3, how can we convert it to the form y is equal to mx plus b? Basically, we're going to have all the y's on the left, the x and the constant are on the right-hand side. So first of all, what we're going to do is we're going to move the negative 4x to this side, to the right side, and then we're going to divide by 2 because we want to isolate the y right here. So then you're going to divide the entire right-hand side by 2, and you'll get y is equal to 2x plus 3 divided by 2. So that sums up our slope-intercept form. Let's continue on. So this is the general equation of a line. ax plus by plus c is equal to 0. For a little bit of detail and background information, let's go over the following bullet points. A, b, and c are going to be constants, so they're going to be numbers. And for reference on how we got this equation, let's continue on. Take the equation y is equal to mx plus b, which we already know is our equation for a line. It's just in slope-intercept form. This is also another variation of slope-intercept form. We just brought all of the terms to the right-hand side. And these are for non-vertical lines, which means that they're going to be slanted lines because that's what slope-intercept form is. So take y is equal to mx plus b, or negative mx plus y minus b is equal to 0, with a equal to negative m, b equal to 1, and c equal to negative b. So let's break this down a little bit. A is equal to negative m. If we look back up at our equation, we see that a is the coefficient for x. Now in the y is equal to mx plus b equation, our coefficient for x is going to be negative m or m. But since they moved it all to the the left-hand side, we're going to take a is equal to negative m. Now b is equal to 1. Since b is the coefficient for y in the general equation, we're going to look for our coefficient for y, and we see that it's 1 since y is just by itself. And finally, c is equal to negative b. Negative b is going to be our constant because if we go back up to our equation, c is the constant, which means that negative b, as the third term of the equation, will be the constant of the slope-intercept form. Okay, so continuing on, we have a vertical line which has the equation x is equal to a. As we went over in the last video, x is equal to a because a vertical line is always going to be on the same x point. So x is equal to a, or x minus a is equal to 0, with a equals 1, b equals 0, and c is equal to negative a. So back up to our equation of general equation, we see that a is the coefficient for x, and if we look back down here, we see that we have nothing in front of x, but x is still there. So our coefficient is going to be 1. Then we see for b is equal to 0. We don't have a y term in the x minus a equation at all. In this equation, we don't have a y term, which means that b up here would only have to equal 0 in order for there to be no y term. And then c is equal to negative a. Negative a here is going to act like the constant in the general equation. So negative a will be the sort of quote-unquote third term, meaning that it's going to be the constant. So c is equal to negative a. Next, in the general equation, if b is not equal to 0, the equation will be y is equal to negative a divided by bx minus c divided by b. So going back up to our equation, if b is not equal to 0, we can move this term, ax, and c to the right-hand side so that we can divide all the terms by b if it's not equal to 0. So that is pretty self-explanatory, but there's a little bit more of description. If we look closely at this equation, we can see that it resembles the slope-intercept form, y is equal to mx plus b. In this case, negative a divided by b is going to be your slope, and negative c divided by b is going to be the constant, which is going to be b and m in this case. Okay, there's just a little bit more, so hang on tight. In the general equation, if b is equal to 0, so basically the opposite of this condition, if b is equal to 0, it becomes ax plus c is equal to 0. So going back up to our general equation, if this term is equal to 0, there's going to be no y term, which means it's only going to be ax plus c is equal to 0. So scrolling back down, ax plus c is equal to 0, or x is equal to negative c divided by a, which represents a vertical line. It's just in this case, a down here can be a fraction, negative c divided by a. Thus, ax plus by plus c is equal to 0 is the graph of every linear equation with a and b both not 0. So they can't be both 0, otherwise you'll just have the c term left over, which means that it's not even a line. Okay, so now let's go over an example. Graph the equation 2x minus 3y minus 12 is equal to 0. The easiest solution for this type of equation is to just convert it into the y is equal to mx plus b form. So we're going to go ahead and do that. In order for it to be y is equal to mx plus b, remember what we have to do. We have to move all of these terms, 2x and negative 12, to the right-hand side. So we're going to move this one over here. We're going to move this one over here. And then we're left with negative 3y is equal to negative 2x plus 12. If we divide both of the sides by negative 3, like so, we get y is equal to 2/3 x negative 4, minus 4. And then in this case, our slope is going to be 2/3, and our y-intercept is going to be negative 4. So our y-intercept is going to be 0, negative 4. Our m is going to be equal to 2/3. Knowing this, let's graph the equation. So our y-intercept is negative 4, so we're going to come down here, find negative 4, graph that point, and then our slope is 2/3. So since slope is 2/3, we're going to have a rise of 2 and a run of 3. If you want, you can even draw your triangle like this, if it makes it easier, if you want to do rise first. So rise of 2, run of 3, run of 3, rise of 2. Okay, so that sums up the entire session for today. Let's go back to the top and review what we did. So, different forms of the equation of a line. We went over point-slope form and how this is the equation of the line that passes through x1, y1 and has slope m. Then we did an example using the points 2, 3 and slope negative 1/3. We graphed that equation, then slope-intercept form was second. This is the equation of the line that has slope m and y-intercept b. Then we did an example 2 with the slope 3 and y-intercept negative 2. Just to clarify, when it says y-intercept negative 2, you simply can write it in this form as coordinate form, so x comma y. Just know that x is always going to be 0 if you have it as y-intercept, because it'll be along the y-axis. Okay, and then we graphed this. Then we learned how to convert an equation into slope-intercept form. Finally, we went over the general equation of a line, where we learned how the y is equal to mx plus b form and the vertical line form can be converted into the general equation of a line by altering the constants a, b, and c. And then we went over a couple of regulations where we found out that if b is not equal to 0, it represents the slope-intercept form, but if b is equal to 0, it represents a vertical line form. And then we figured out that the general form, ax plus by plus c, is the graph of every linear equation within b both not 0. Then we did an example with this form, and there we wrapped it up. So that sums up today's video on the different equations of a line. Hopefully you learned a little bit more about lines today in continuation to the last video, and please share this with anyone who you think it might benefit. Also, like, comment, subscribe, and let me know which topics you would like to learn about more for the future. Thank you.